My name is Clifton Cole. My major is architectural engineering.
I'm Vincent Ogilvie, and my major is mechanical engineering.
I'm Josh Curtis, and my major is computer engineering.
My name is Anthony Kaysen, and I'm an industrial and systems engineering student.
My name is Jeremy McClooney, and I'm an electrical engineering student. We are the problem solvers, and it is our objective to create the most cost-efficient and effective product for determining whether or not an individual is impaired.
Current solutions for impairment include some examples like the concussion test for football, when you have to count the number of fingers on one's hand that test the person's memorization skills. They also have tests for balance that make the person stand on one leg and test how long they could balance on one leg. And then another example is the horizontal gaze test, where one has to follow the person's fingers with their eyes.
What we initially did to develop our project was to look at the current solutions for criteria of impairment, and then we tried to develop something that followed the constraints of our project. This meant that we had to research the different solutions and then use a decision matrix to incorporate the best solutions into our product. Some of the factors were price, portability, effectiveness, and difficulty. This led to our product being based on judgment skills and motor skills.
Here is our amazing impairment tester. What's going on here is that the subject will hold on to the knobs on each side of the impairment tester, have their two thumbs on the two buttons in the front of the impairment tester, and their two pointer fingers on the two buttons in the back of the impairment tester. With this being the case, they will twist the knobs and strike the buttons to move the ball throughout the maze that's inside of the impairment tester in the allotted amount of time to the 5 designated points in the maze, and then get the ball to the end point in the maze. This is supposed to test the subject's judgment and motor skills to determine if the subject is impaired or not.
We decided to compromise by incorporating parts of our previous designs to come to a final prototype which could cohesively and accurately test the impairment levels of a person. Before, we were inquiring about the possible use of electric circuits in our device, but because we wanted our device to be more precise, we decided to exclude the use of circuits in order to further the accuracy of our tests.
The last thing we have to do is get our product on the market. After that, we have to get feedback from the buyers to see how well the product is working. The last thing we have to do is perfect the prototype that we already have designed.